All right, welcome back, guys. So we are about to start our next lesson. Now, this lesson is going to be on interpreting again, but this time we're going to be talking about linear functions and both of the parts of a linear function, both the rate of change and the initial value. So let's jump right in. Our learning objective, specifically for this lesson, is that we're going to be interpreting. Now, to begin with, let's make sure we remember what interpret means. Interpret means that we are going to take a mathematical idea and then write it in normal language. So we're going to interpret, and we're going to interpret two concepts of a larger concept. Now, the larger concept is going to be linear functions. Now, we're very familiar with linear functions, and hopefully we're familiar with the two other concepts that make up a linear function, but these are the two things we're going to be interpreting today. We're going to be interpreting rate and initial value. So today's learning objective is we will interpret the rate and initial value of linear functions. Okay, so let's look at our concepts. All right, so our overall concept is linear functions, and linear functions are relationships that have a constant rate of change and an initial value. Now, this word right here, linear, has line as part of it, and what makes a linear function linear is that it has a constant rate. So when we look at this example here, I see that I have a straight line, and that straight line has a constant rate, which I'll talk about more in a second. But that's what makes a linear function. Whenever I have a straight line that's not vertical, it's going to be a linear function. Okay, well, let's talk about the details of a linear function, two other concepts that make it up. The first being rate of change. Now, for rate of change, the definition here says rate of change is the ratio, that's a comparison, of two related changing quantities. So let me help you see the important parts of rate of change. It's going to be that we have two changing quantities. A rate shows how two things are changing together at the same time. Well, let's read this example and see if we can find the two quantities that are changing. It starts with, Sarah is saving money to go to Adventure Park. She begins with $10 and saves at a rate of $5 a day. Okay, so I read two numbers there. She begins with $10. She begins with $10. Well, $10, that's just one quantity. There's not two, and it's not changing. So that doesn't seem like that's my rate. It goes on to say, and she saves at a rate of $5 a day. $5 a day. So dollars is one quantity, days is two quantities. That's the rate. So I know that's the rate because we have two quantities there, dollars and days. It goes on to say the graph below models this relationship between the number of days she's been saving and how much money she has in total. Well, let's look at the graph now and see if we can understand where the rate of change is on the graph. So I see that I have a line, and I believe I have an animation that might help us see the two changing quantities. Well, let's look at a point as it moves up the line and see if we can see how the two things change together. First off, as the point moves up the line, I see that two things had to change. Dollar amount increased, and so did time. And then I see that happen again. The dollar amount increased, and then time also increases, 2 more days, and then another $10 and another 2 more days. So I know that that's a rate because two things are changing, and a rate of change shows the comparison of two constantly changing things. It's constant because that pattern, that stair-step pattern, happens over and over and over again, and it does not change. That's what makes a constant rate of change. Okay, well, let's now look at our second idea, our initial value, the y value where a function begins. So the initial value is the y value when a function begins, when a y value. Okay, so let's look at the graph. I see I have y here, and the value of y is dollars. Okay, so the initial value, back up to the definition, the initial value is the y value where a function begins. This is the critical part here. The initial value, the word initial, tells me where something starts or where something begins. So that's our beginning value. Well, on the graph, I see that the graph starts, the line starts right over here at 10. All right, so that might be our initial value. Let's go back to the description of this situation and see if we can find out our initial value or where the function begins. Sarah is saving money to go to Adventure Park. She begins with $10. Well, actually, hold on, right there. The word begins with $10. That's telling me where this function starts. That's the initial value. All right, so let's look to see. I do have an animation here. Yes, begins with $10. Now, let's double check where that is on the graph. The initial value tells me where the function begins. I see that the line starts way over here on the y-axis at 10, and yes, that is the initial value. It starts at $10, and then the constant rate of change is where it goes from there. So let's take these two ideas, rate of change and initial value, and start interpreting them. Okay, so let's go through interpreting the rate and initial value of a linear function. To begin with, we always want to read the situation that we're talking about. But this time, as we're reading it, we want to identify and define the two quantities, the two things that we are talking about, the two things that are changing in this particular problem. So we want to identify and we want to define the two quantities. Okay, so let's go ahead and read it and see what we have here. The coordinate grid shows the graph of a linear function that represents the amount Jocelyn earns each week at her job. Okay, then it says the total amount she earns is based on the amount of her sales. Okay, the total amount she earns. Okay, how much money she makes is based on the amount of her sales. Okay, so I think that makes sense. The more she sells, the more money she should make. Well, let's look at the graph and see if we see that happening here. On the graph, I see that I have a linear function. I have a straight line and it has a constant rate of change. I also see at the bottom for my x value, right? This is going to be our first quantity, x. We're talking about amount of sales in thousands of dollars. Okay, that's a little tricky. We're used to these numbers on the x-axis, 2, 4, 6, 8, just meaning like $2. But this says the amount of sales in thousands of dollars. So the x value, let's say this 2, to make sure we have a good understanding of it, means that she actually sold $2,000 worth of sales. Okay, so we've identified that the first quantity is her sales, and that's her x value. So let's go ahead and define that. X equals sales, and this time we're talking about in thousands of dollars. Okay, well, let's look at our second quantity. Our second quantity would be on the y-axis. Let's go ahead and change colors here. On the y-axis, and the y-axis, it tells me it's the amount of her earnings. Okay, so this could be tricky. These are both dollar amounts, but the x values are talking about how much money she has made in sales, while the y value tells us how much money she actually makes herself, how much her paycheck will be. So let's go ahead and define that one. Y would be her earnings, and that is again in dollars. Okay, so step one is done. We have identified our two quantities, and we've defined them both. Now the next step, step 2, identify or calculate the rate of change using the units in the calculation. Okay, so this is new. I don't think we've done this before, but I think it'll help us in our interpretation. We're going to use the units in our calculation. Okay, so how do we calculate rate? Well, at the top you see here, we have rate equals y2 minus y1 over x2 minus x1, or the change of the y values and the change of the x values. Well, since we have a graph, let's do the first one. How do the y values change and how do the x values change? So let's get this set up. We're going to begin with m equals, and in the numerator, we're going to put how the y value changes. All right, well, how do we do that? Well, what we're going to do is we're going to pick 2 points on this line. I'm going to pick 2 points that I can easily read. I can read this one, and I can read that one. Let's see, how does it change? How does this line function change going from one point to the next? Well, if I start at the one on the left, how do I go to the one on the right? How does the y values change? Well, y values go up or down, so I have to go up from 600 to, actually, what is that? Well, on the side of the graph, I see I have 600, skip a line, 1,000. So what's halfway between 600 and 1,000? We're counting by even numbers, 600. You know what? Look, 2, 4, 6. It's 800. It's halfway between 600 and 1,000 is 800. So this should be $800 right here. Okay, so what is the, oh, actually, so now that I know that that's 800, how much did I just increase my y value there? Well, if I started at 600 and I go up to 800, that's an increase of 600 to 800, that's $200. So my Y value increase was $200, but let's be specific. $200 of her Y value is earnings. So I'm going to put $200 of her earnings. Now, what about the change of the X values? Okay, well, to do that, I have to move from where I ended up or left off on the orange line here, my Y change, to go to this second point. This time I'm gonna have to go horizontally. Okay, well, I see I just have to go over 2 here. How far did I go over? I went 2 lines, and I went from 2 to 4. Okay, well, if I went from 2 to 4, that's just 4 minus 2 is 2, so it went up 2. Something doesn't quite feel right, though. I went up 2, down on the x-axis, amount of sales in thousands of dollars. Okay, so she didn't just go up $2 in sales, she went up $2,000 in sales. I'm going to go ahead and leave it as 2 because that's what we have there. But this time on the rate of change here, I'm going to write 2, and then I'm going to write sales in thousands, just to remind myself what I'm talking about here. So her earnings went up $200 and the sales went up $2,000. Okay, well, now I've got this 200 over 2. I've got my units. Let's simplify this. Let's make this be a easier fraction to look at. So I've got 200 in the numerator, 2 in the denominator. Both of these numbers, I can divide this one by 2 and this one by 2. So let's simplify this and see what we end up with. We end up with 200 divided by 2 is $100 in earnings. And that's being compared to 2 divided by 2 is going to be 1. And we were remembering that that $1 is actually thousands of dollars in sales. Okay, now I need to be able to explain what that means. So now I'm going to go to step 3. So step 3 says interpret the rate. And how we're going to do that is we're going to interpret the rate by using details from the situation. Okay. And then we're also going to compare the changing X value to the changing Y value. So we're going to use the X value first in our interpretation, and then our Y value second, as in miles per hour. Miles would be our X, hours would be, no, that is not right. This is really hard. No. Okay, so let's interpret the rate. Now, this is the third step, interpret the rate. Now, it says to interpret the rate by using details from the situation, right? So I need to make sure I'm talking about that she's earning money based on her sales. And then I also need to compare the X value change to the Y value change. So I need to compare the X values to my Y values. Now, instead of writing this out, I have it typed so we can, read it. And let me help you understand what I would write here. So going back to my rate of change, I have $100 in earnings. All right, so here's my Y value, $100 in earnings over $1,000 in sales. Okay, so $100 in earnings over $1,000 in sales. So if I want to compare the X values first, I would say every time she has $1,000 in sales, that means she's going up in her earnings by $100. Okay, so let's see what my explanation would be. The details I'm including here is what the dollars are talking about. And what I have is the meaning of the rate of change of the function is that for every $1,000 in sales, this is my X value, I'm using this part first. For every $1,000 in sales Jocelyn makes, she earns $100. So notice I use the words from the graph, right? Thousands of dollars in sales, I put thousands of dollars, $1,000 in sales. On the y-axis, it says amount of earnings in dollars. So I put earns $100. So the rate of change, or the slope of this line, is telling me that for every $1,000 in sales Jocelyn makes, she earns $100 in her paycheck. Okay, well, that was a lot. Let's see what the next problem has, and let's see how we're going to interpret the initial value. This problem, it looks exactly the same, but I have a different question here. I see that instead of A, it says B this time. So let's go through our situation again, our steps again. Read the situation, identify and define the two quantities. Let's just make sure everything is the same here. So the coordinate grid shows the graph of a linear function that represents the amount Jocelyn earns. Okay, now when I'm reading this, the amount Jocelyn earns each week at her job. The total amount she earns is based on her amount of sales. Okay, so these are the two quantities we're talking about, the amount that Jocelyn earns and her amount compared to her amount of sales. Well, when I look at the graph, okay, that holds true. Right here, X is the amount of sales in thousands of dollars, and Y is the amount of her earnings in dollars. Okay, well, the question says, what is the meaning of the initial value of the function? So I need to be able to explain what is the meaning of the initial value. Now, we went through the first three steps on the last problem, and here you say it says, if necessary. Well, we don't need to calculate the rate of change in this problem because it's talking about the initial value. So we're going to go ahead and drop all the way down to question, or to step 4. Identify the initial value and its units. Identify the initial value and its units. Okay. So if we go back to our concept, in fact, let's actually go back to our concept. Our concept, the initial value was the Y value where the function begins. Okay, on the graph, I can see that I have it circled in orange down here. That's $10. That's how much Sarah began with. Okay, let's go back to our problem. Now, on this problem here, we are talking about, or we are looking for the initial value. So on the graph, I see, where does this line begin on the y-axis? It starts right here, but there's no number there. All right, so we're gonna have to figure that out as our first step in order to identify and interpret the initial value. So I see that at the bottom here, we start at 0. At the first line, we start at 200. So that means we're counting by 200s. Each line we go up 200. Okay, well, that makes it really easy. The next line is going to be 400. So let me go ahead and write 400 right here. And what I have, and what I see right away, is that my initial value in this situation is 400. So let's go ahead and write that. I'm going to write B, the variable we use for initial value, is equal to 400. But let me be careful here, because it says in the step to use its units. So I'm not just going to write 400. What is the Y value talking about? It's talking about the amount of earnings in dollars. So I'm going to put $400, but I'm going to be even more specific. It's not $400 in sales. It's $400 of earnings. So I'm going to go ahead and write earnings here. Now, I have to interpret what is the meaning of that initial value of that $400 in earnings. Okay, so let's go through the remaining steps here. Step 5, interpret the initial value by determining the beginning of the situation. All right, it doesn't say determine the initial value. It says, what's the beginning of the situation? So let's think about that for a second. The coordinate grid shows the graph of a linear function that represents the amount Jocelyn earns each week at her job. Okay, so this is for a week. The total amount, okay, the total amount she earns is based on her amount of sales. So it's not just based on her amount of sales. There's something else going on here. The amount of sales based on her earnings is the slope of that line. So as we go up the line, as she has more sales, her total amount increases. Okay, that makes sense. But what does this mean that it starts at 400? Well, that must mean that at the beginning of each week, she earns $400 without making any sales. Okay, so I guess that means she's going to get paid no matter what. She just makes more and more money based on her sales. So to interpret that, I'm going to say, go ahead and pull up my sentence here. The meaning of the initial value of the function is that Jocelyn earns a base salary of $400 per week. Now, I've included a word in here that we might not understand where it came from. So let's go back through. The meaning of the initial value of the function, I just included the question in the answer, is that Jocelyn earns a base salary. This part right here, we might not be familiar with. The word base means where we start, like home base is where the baseball player begins. So her base salary means her salary where it begins. Her base salary is $400 per week. Now I included that because this is a test type question and we should know that kind of language. Let me show you another thing that we could have written that might be more familiar. I could have written, the meaning of the initial value of the function is that Jocelyn earns $400 per week before any sales. That might make it sound more familiar to what we've done in the past. I could have written the meaning of the initial value of the function is that Jocelyn earns $400 per week before any sales, because as soon as she starts making sales, her earnings are going to go up, but it always starts at 400. That's the meaning of the initial value. Okay, so we've interpreted the rate and we've interpreted the initial value of a linear function. Now it's time to move on and do some practice.